So yeah, I'm Arnaud. So the talk today is going to be about the first talk, because we have 3 talks. The first talk is about Clickhouse and Iceberg, to make it short. And so the agenda is going to be, it's about 30 minutes. And so I'm going to introduce things, speak about Clickhouse and Iceberg, Clickhouse plus Iceberg, and then a demo, which is kind of daring, but I'm at Jump, so it's on network, so it will be easier. And then 5 minutes for questions. So, who I am? Arnaud. So I'm the database team lead at Jump. I've been at Jump for about 10 years, and I've been in this industry for 25. And I've met Jeremy in the audience here in a MySQL meetup at some point. So Jumptrading is a leading data and research-driven trading business. So we are based in Chicago. That you are actually in the headquarters here, and we have 10 global offices. We trade all asset classes, all time horizons, and including crypto. We have a capital branch, Jump Capital, who organize these events here. And so, yeah. So Clickhouse is a database. As I said, I'm Arnaud from the database team. It speaks SQL. It was created in 2009. It's a column store. I'll come back to it if you don't know what that is. And it has a very nice research paper that explains it in detail. I'll send the slides so you'll be able to see for yourself. It has over 2,000 contributors, and you can find that if you go to fiddle.clickhouse.com, you can use the latest version of Clickhouse and go to the system table and monitor the contributors. Also, it's quite popular. Like, it used to be less popular when it started, but then it quickly climbed the ranking. This is the star ranking for those who know GitHub. So in GitHub, you can star a project, and Clickhouse has quite a lot of stars and overtook nearly all the competition except Elastic. And so why is Clickhouse interesting? It's interesting because it's fast, it's open source, it's very stable, you can do a lot of things with one executable, it runs everywhere, it has 43,000 stars. Last year was 39. Large community. And the great feature that it is built with performance in mind. And that has to do with the founder, Alexei, who was here last year. So if you missed that, you can watch the recording. It's still there. Runs everywhere. So Clickhouse is present on the cloud, obviously, clickhouse.com. And you can run it whenever you want, and wherever you want. You have no vendor locking. It has pretty good enterprise support. It's still actively developed, and it's in C++. It's very fast, very efficient. And so if you want to know where it's used, I'm going to give you some examples, but it's essentially good at real-time data analytics. So it's a real-time data warehouse. So for example, if you have metrics in your system, you can send it to Clickhouse, metrics, logs, traces. It's good for BI. It's like kind of versatile, which is why I like it, because you don't need a database for everything you do. You want to do vector searches, you can do vector search, and you get pretty decent performance in Clickhouse. And if you want to improve it, you can. It's like open. So big names are using it. It was not the case back in a few years back, but yeah, Cloudflare was one of the first adopter. Netflix, Uber, Lyft, OpenAI, Anthropic. And there's a famous quote from one guy at Tesla called Alon Tal. He is basically my equivalent at Tesla, and he says that data in Clickhouse is better than data anywhere else. So that tells you how well it is regarded. And most metrics from the robots, for the factories, for the the cars, they're all going to Clickhouse. And they ran some tests, and they could insert 1 quadrillion rows in it. And so it was pretty, there's a presentation, you can Google for it, and I have the link for the presentation there. Okay. Performance matters because, of course, performance these days translates to money on the cloud, right? And one Clickhouse node can do a lot. And one of the projects we had replaced 130 something into 10 Clickhouse node. So it gives you the idea of how efficient it is. Why is it fast? Because it's well designed. Especially what I like is that it's performance driven. And when there's a new release, it gets new features pretty quickly, bug fixes and performance improvements. Performance improvements are not typically the things you find in such projects. The other reason why it's fast is its design. So it inspired from the LSM merged LSM tree, and so it merges the data. So it inserts the data as it comes in immutable parts, chunks, and there's a background process that merges it so that you don't end up with millions of files, right? It's important that the number of files are controlled. So how does it happen? It writes parts, and the parts have columns, so the data is organized by column, hence it's a columnar database, and it has a sparse index, which is usually in memory, which they call the primary key or the sort key. I think more like the primary key, and all the columns, the values are sorted by a sort key as well, and that's very. I will show you why it's important. So that's. The way the row is reconstructed from the columnar chunks, so the columnar data is in the bin, and then you have marks that reconstruct the row. And they're organized as granule, but I think the next speaker is going to discuss that better than me. So then the parts that are immutable are merged, and that's all. So bigger parts means less data on the file system, and so it's essential. And here's a typical Clickhouse tables for Solana, for example, Solana block, and you can see they can specify the engine, you can specify the order by, which is basically the way the data is sorted physically. That's quite important because sorting will influence compression. And compression is money as well. Like if you have 1 petabyte of data and you compress 20% more, you save 20% of the cost. So it's kind of, everything is charged these days, right? And so partitioning is also an important feature in Clickhouse where you can, this is important to manipulate the data, you can age the data, you can TTL, you can automatically, you can move it, you can, so you can have a handle on it. So that's it for Clickhouse. So before I introduce Iceberg, I need to tell you about the file formats and the main data architectures. So file formats, typically an Excel file, a CSV file, a Parquet file, which is columnar 2. JSON is also a file format, so that's very simple. And the main data architecture, you have the data warehouse. So Clickhouse is typically a data warehouse. It has a bunch of nodes, local storage, shared nothing architecture, and new kind of architectures have appeared in the last 20 to 10 years. The data lakes. Data was on Hadoop with different formats, CSVs, etc. And people thought that we could scale. Yeah, we could scale the storage, but there was a price to pay in reading that data. Because if you read a bunch of CSV gzip files of 1 petabyte, it's not going to work very quickly. Maybe it's going to burn a lot of electricity. The data lakehouse came as a better alternative on Object Store. Object Store, everybody knows it's a game changer. And Parquet files, which are one of the file formats that I presented, are usually the standard these days. So where, and engines like Clickhouse can become query engines and query that lakehouse. So that takes me to what is Iceberg, because Iceberg is exactly that. It's an open source table format which is going to leverage Object Store and Parquet on the cloud or on whatever storage you have. It was invented by Netflix, and that basically puts some order into that data lake and creates this concept of lakehouse. So that's the Iceberg architecture. So Iceberg needs a catalog that gives you the latest version of the data. And then it stores the data in different layers. So there's the metadata layers. And there's a data layer. But the interesting thing is that everything is stored on an object store. So this on the right is MinIO. And so you have like the metadata. That's basically my demo. You have the metadata that is a bunch of files that are really small, like metadata files. And then the big data is actually under data. And so that's the way. And if you look at the kind of file format that you have there, you have JSON, and you have the latest version of the data is pointed by the catalog, and it's going to be one of those metadata files. And then they're going to point at manifest lists and manifest files that are going to be in Avro. And so if you have an engine that can read that, you can basically have a table interface, but at scale, because this is scaling like infinitely. And if you have an engine that can read that, then you can do a lot of things. You are not limited in the storage that you have in your warehouse. You are unlimited. Any questions on that? Or it's understood? So Iceberg is very close to Clickhouse in terms of concept. So I presented the parts that are immutable. You can replace them with Parquet files, etc., etc. You have the notion of sort key and partitioning key, but I skipped that because I need to show you the demo and I want to have time. So this has a lot of benefits. I'm going to skim that very quickly. So schema evolution, hidden partitioning, it's an open standard. And basically, instead of redoing it your own, if you want a good table format, you can just take that one. It's pretty good, and it's been adopted by the whole industry. And so the whole industry is Snowflake, Databricks, DuckDB is an open source player, and of course Clickhouse. And this is good. This is a market. There's competition, and it's good for everybody. And that's why I'm happy to discuss it today and to make it to reach it to a wider audience. So the talk is about Clickhouse and Iceberg. And so I already said that Clickhouse was fast. It was one binary. And you can run Clickhouse in the cloud, on the cloud, like in the cloud, like Clickhouse.com offers that. They're here today if you want to discuss a potential project on their cloud. I think they'll be more than happy to discuss it. But the data warehouse is implemented with this Clickhouse server binary. You also have a replacement for Zookeeper called Clickhouse Keeper. You can run as a client, you can run as Clickhouse local, and you can also run it in process. So it pretty much covers all deployments. If you want to run it as a query engine, which I will show, you can use Clickhouse local. And if you want to scale that, you can have as many workers that you want. You can basically break what is works as a one binary into distribution of that one binary over different stacks. So you can compact the files so that they don't grow to millions with the same Clickhouse server. And you can clean the parts that have been deleted or the snapshots that are old with the same Clickhouse server. So that's why I'm very excited about it. And then it can integrate to REST API catalogs that are open source. So if we combine everything, which I will do in the demo, you will be able to do interesting things. And my conclusion for those slides that Clickhouse, my thesis is that Clickhouse can scale and query efficiently any data on any compute and on any latency. That's me, but because it's real time, you can see data from milliseconds ago, and you can see data from 10 years ago using the same engine, which is kind of nice. And in my demo, I will show you that you can also, this is pretty new, you can write Iceberg within Clickhouse, so you don't need any Java. You can do everything with Clickhouse. So that comes to the demo, and I have about 10 minutes. So I'll leave time for questions. So I'm going to share demo here. So this is my environment. So I'm at Jump. I can make it bigger. So I'm somewhere in the New York taxi data. So it's a data set that's well known. You can download the Parquet files. So basically, I didn't want to create the Parquet files. They already exist. So then I have a bunch of Parquet files. If you go to Clickhouse, they tell you how to download them, and most of the demos use it. So I have a bunch of Parquet files, not many, right? 72 total, but I only use a subset of them. So what am I going to do? I'm going to use what I told you I would use, which is Clickhouse local. And I have a catalog running. So the other window down at the bottom of the string is a catalog. So you can assume I have a catalog. I have an open source catalog. And so I'm going to run Clickhouse local with maybe a config that I have. Maybe that's going to help. And so what I'm going to do is I'm going to create, so it's a process. I have no data attached to it. I'm going to allow Clickhouse to see Iceberg, and I'm going to point to a min.io server, but this could be S3 for this demo, and I'm going to use a REST catalog, which is at port 5000, and the min.io is at port 9001. So let's see what it does. So it works. And so this database is Clickhouse Meetup. So if I do this, go to Clickhouse Meetup, and I can do show tables, and that's going to list the tables directly into the catalog. So I have the Meetup New York taxi data set, so I can just run some queries on it. Okay, I need to quote here, backtick. So I have 1 billion rows. See how it's quick? It's very quick. And I'm going to run some queries that I've already pre-computed. I have in my history. So this is the same thing. So I'm doing a group by without an option and using the new option that is the V3 parser, which is faster. So let's see if that works. So it takes about, there's a call run and the hot run. So I can run that 2 times to mitigate the cache problem. But as you can see, I can get this data from the object, so in 1 second, to process 1 billion rows. So it's 1 billion rows per second. It's there. And if I'm using the new V3 parser, it's 1.5 billion rows per second. That's kind of nice, right? Manipulating a data set that comes out of nowhere that has 1 billion rows in an executable that has not even a database that I configured. It's good, right? I mean, that's pretty awesome software. And so what I want to show you here is where this is stored. It should be stored in the min.io console. And so I have this data, and I literally imported the Parquet file that comes from the dataset. I didn't post-process it. I can just query it live. And the metadata, as I said, of course, we don't see it fully here, but you can trust me, this has the JSON and the metadata JSON, etc. So that's the same thing. We can go there. Yeah, it's going to be exactly the same. So yeah, now we're going to do something interesting. So yeah, I can do the same thing with the files actually. So because I have the raw files on my disk, I can do the same query. I think I presented So this was the average distance, right? So I'm going to give you the average distance to be fair comparison. Average trip distance of this New York data, the taxi data set. And I'm going to run the same query on the same data directly from the file system. Oh, so okay. I need a special. I need a special. Yes, I didn't put the session variable. It's because those Parquet files are not perfect. But if I do this, it should work. Okay. So you see that reading the data from the file system is a little bit faster. We got 1 second, like maybe 7% faster, and this is the core run. But I also process faster, but it's expected, right? There's no network latency, etc. So, but we're very close. Like it's not like 10 seconds and 1 second. So that shows you that Clickhouse is also powerful to manipulate the raw Parquet. So if I wanted to post-process them before writing them to a database, I could do a lot of processing using this file function because the files are also there. So so I have time to show you another interesting thing, is that I can write data from Clickhouse to Iceberg as well. And that's a really new feature. But I was surprised that it was pretty good. So in order to do that, I need to enable some stuff. And basically, I need to create a new table that points to the same directory, the same MinIO. So I'm going to do MinIO to MinIO. But I'm going to process it through this Clickhouse process that has no state. But it knows about 2 Iceberg tables. So that's exactly what I'm doing here. So I created a new table in default. So it has the same data structure. And to my knowledge, this thing should be 0 rows, right? And you can trust me, it's in MinIO because that's where I created it. So this should be 0 rows, okay? And I'm going to write data. And it's going to take a few minutes, and I have a few minutes, so it's okay. I'm doing something actually just not insert select. I'm going to sort that 1 billion rows because I want to show you some good properties of sorting the data. And so we're going to execute that. I can put it here. So I'm going to put some variables that we need to have. And I'm going to do an insert select between the data that comes from Clickhouse, or the data that comes from the Clickhouse Meetup database that I showed you in MinIO. I'm going to order by it by the pickup time here, so 1 billion rows sorted. And then I'm going to insert that into a new table that is also in Iceberg. So I'm going to do Iceberg to Iceberg. And let's run that. And so it's pretty good. It runs, like, the status here tells you that it's doing at 15 gigabytes per second. It's actually sorting the data. And then it's going to have to, what is that? No, it's running, okay. It's still running. So, and it's going to insert this data. I think so the 1 billion row data set is there. And so it's inserting into Iceberg. So I can show you that live with, okay, so resume. So that's live. And I can show you that in the object store. So the object store, the MinIO is there, the MinIO console. So I have a new table from Clickhouse. So this, I'm doing really one table to the other. And what do I have? I have the new metadata, and I have the data, and it's doing it in 500 megabyte chunks, which I specified because I want less files than the original. Here I had like about 100, between 100 and 200 megabyte, and now I have data that is, less files. So that I configured. And so let's see the progress of that. If I come back to this. So yeah, it should last about 3 minutes. And so yes, I think when that completes, that will be the end of my presentation. I can take a few questions, but I will show you some properties of doing that, because if I'm doing this processing, it's for a reason, right? I want to show you that it is achieving something. So yeah, if we go to here, we should see the number of files increasing. Yeah, so they're increasing a little bit. Yeah, I hope that's working. It's not the demo effect. Yeah. Okay. Okay, I'm going back here. So hopefully it's working. And then I run like my point is that this data should be smaller because I sorted it. So I will show you that, and it should have less files as well. So it's expected that it takes longer than just row insert select because of the sorting. And yeah. So then I will run some queries, the same queries, to show that it's working. Okay, so I have to resume. Okay, it's been done, 3 minutes, so I was right. I tested it properly. So I know there was a bit of suspense here, but yeah, so I need to. So Clickhouse has a nice history stuff here. So you can see, for example, so here I can, so this is my original table. My original table had like what? 13 gigabytes and 82 files. And if I run the default one, which I created, so you have autocomplete like this. So it should start with, okay. No, let me check. I can go to default and see. Okay, so this is the name, so I can just copy and paste that name, and you should see that it's smaller. Okay, unknown table identification. Oh, default, yeah. Show default, yeah. Okay, so that's something that forgot, but Control R, and then I need to attach it. So I need to attach this way. Maybe in my history, okay. So this is the correct one. Yeah, this one. And it was 13, it's going to be 10. Okay, and less files. And yeah, that's it. That's mostly the end of my talk, I think. So thank you.